Hello students, today's experiment we are going to perform a titration, a simple neutralization reaction of KOH, potassium hydroxide and oxalic acid. It's a dicarboxylic acid. These two react to form potassium oxalate and water. So here you are given the normality of potassium hydroxide, which is 0.09 normal. We have to find the concentration of oxalic acid in terms of normality and grams per liter. These are the requirements: burette, pipette, conical flask, beakers, stand, funnel and tile. These are the chemicals required. Now we'll start with the procedure. Now we'll start with the rinsing of all our apparatus. We'll start rinsing the burette. Repeat this rinsing 2 or 3 times. Rinse your funnel, because every time for every experiment you are going to use a different solution. Rinse your conical flask. After rinsing with water, we will rinse the pipette and the burette with their respective solutions. In our case, in the burette we have KOH solution. So we'll rinse the burette with KOH solution. For the pipette, we'll rinse it with oxalic acid. Now we will fill our burette with potassium hydroxide. We'll take the funnel. We'll try not to bring any bubble formation in the whole burette. Now we will take the oxalic acid through the pipette. Now we have the indicator phenolphthalein here. Remember, in the burette, the solution of which we are knowing the concentration is called a standard solution. This solution we call it as the titrant, and the solution which we have in the conical flask is called analyte, because we are going to analyze the concentration of this oxalic acid. Now I have already told you that phenolphthalein in acidic medium is colorless. So in conical flask we have oxalic acid. We will pour 2 or 3 drops. It is colorless. So our end point is colorless to light pink. Bring the burette to your eye level and then shake it while dropwise addition of potassium hydroxide. You will notice a slight appearance of light pink color at the bottom, which is getting disappeared. The moment it gets permanent light pink, we will know that the oxalic acid is completely neutralized by the potassium hydroxide. Now, this is the appearance of our permanent light pink color. Now we'll notice that our reading is exactly at 9. The lower meniscus of this solution is at 9. That day we talked about the least count of our burette. The least count of our burette is 0.1. So in our initial level or in our initial reading, we had seen that it was at 0 ml. Our final reading was 9 ml. So the difference will be final minus initial reading, which is 9. Again, we'll rinse the conical flask with water and the pipette with oxalic acid. So, we'll clean the pipette and the conical flask with the respective solutions. Again, if you get the reading as 9 ml, supposedly we get 3 constant readings of 9 ml. We'll write here our reading as 9, which is our consistent reading. You have to repeat your experiment or you have to repeat your titration till you get the constant reading. So in the statement, we'll write that this much ml of this concentration of KOH is required for neutralization of 10 ml of some amount of or some concentration of oxalic acid. To know the concentration, again we'll apply our normality equation. We are knowing our burette reading is 9. So our N2 will be 0.081 normal. This is the concentration of our oxalic acid. For knowing the grams per liter of oxalic acid, we will multiply the equivalent weight of the oxalic acid with the normality, which comes as 5.1 grams. In our final table, we'll write the normality and the grams per liter.